Okay, for a question like this where you're given the equation of the transmission of a disease, Rx is equal to K times X times a population size. So we'll say in Canada the population is 34 million. And the number of people that are already infected with the disease is what X stands for. What we've got is an equation where this number changes depending on the ease of transmission of the disease. So if we've got an airborne, highly healthy virus that can sit on a surface or can stay in the air, we could have a transmissibility here of, we'll use your number, 0.025. So this is going to give us the number of new cases that we're going to get in a particular week. We want to find out how many or where this maximizes. At what incident of infection are we going to get the number of total infections that we've got in a particular time maximizing? The equation is given here in this case. We don't have to derive the equation. All we have to do is find the maximum. To find the maximum, what do?
Derivative.
Take a derivative, set it equal to 0.
Right.
Look ahead. Should I take the derivative right now?
No.
Or should I do something to this before I take the derivative?
Boil it first.
Why?
There's brackets.
Because it's brackets, that makes it a UV rule, right? So look ahead, don't just take a derivative. If you can make the derivative easier, do it. So take the bracket off, 0.025x times 34 million. Somebody please.
250,000.
250,000.
850,000.
Okay. 850,000x minus 0.025x squared. Then take the derivative of this function.
That's 0.5.
850,000 minus 0.05x. That is the slope of the previous equation. We are looking for a maximum, and a maximum occurs when the slope becomes 0. Solving for x. This term moves to that side, becomes positive. And divide by 0.05.
1.7 times 10 to the 7.
Okay, get their calculator off that.
Okay, well, 1, 2,
Yes.
3, 6 zeros with a 7. There you go.
Okay, with this particular transmissibility number right here, the one we picked, we started out with a 34 million population. This is telling us that the peak incidence is going to occur at 17 million, right? Halfway through?
Inflection point.
Well, no, it's going to be a maximum. We're going to have more and more people becoming infected with this disease until 17 million, till half the population has had the disease,
Then there's
and then it's going to start dropping off, the number of new cases per time period.
Okay.
And once half the population has it, then there's fewer people out there that, to contract the disease.
So there's no inflection points in this, right?
No.
Only
No.
for things with like, not squares, but
Yes.
cubes.
Yes, that's right. As soon as you have squares, it's got to be parabolic.